Good morning, everyone. Our topic for today is derivatives of quotient. When you've had quotients of polynomials, you've been able to find derivatives by simplifying the polynomials before using your power rule. For instance, you've found the derivatives of y equals x squared minus 2x plus 1 all over x minus 1 before. Using the specific example above that in general the derivative of yx equal to ux over vx is not given by the y prime x equal to u prime x over v prime x. As long as you can simplify the quotient to a simple polynomial before taking its derivative, you're okay. Often, however, that can't be done. For instance, yx equal to x over x squared minus x plus 1.
Since we're interested in specific kinds of functions that are quotients of other two functions, we want to find the small change in y in terms of corresponding small change in other two functions, in this case u and v. Now, small changes in each of those will lead us to u plus derivative of u and y plus derivative of y respectively. So we can write the value of y after a small change as the quotient of u plus derivative of u over y plus derivative of y. Now, the derivative of a function is just the limit of the difference of the new y value after a small change less the original y value, divided by how far we had to move, or derivative of x, to get to the new y value. The limit of that as the distance we had to move goes to 0. So, let's go through that process one bit at a time, recognizing that f open and close parentheses x plus derivative of x is the same thing as y plus derivative of y. We can rewrite our definitions of this derivative in the form of deltas. It's like this. You can replace y plus derivative of y with u plus derivative of u over v plus derivative of v, and y with u over v, and evaluate that limit directly. If that bogs you down or seems incredibly complicated, I'll take you through it step by step. Here's the step-by-step derivation.
The rational expression is your example have no asymptom. Asymptotes are not assured. If the power of the numerator is greater than the power of the denominator by the 1, then there is no horizontal asymptom. If it exceeds by exactly 1, then it has oblique asymptom. Each one of those you posted result in quadratics, which are parabolas, no asymptom. The later one thus cross the x-axis so it's a complex roots. For instance, try x raised to 4 plus 3x cubed minus 2x squared plus x minus 1 over x squared plus 4x plus 4. Upon dividing it, we will get 13x plus 7 over parenthesis x plus 2 close parenthesis squared plus x squared minus x minus 2. So our answer will be x squared minus x minus 2 is equal to open parenthesis x minus 2 close parenthesis open parenthesis x plus 1 close parenthesis. That's all. This is nonlinear fraction.
Hello everyone, and today I'll be talking about rational functions. There are different types of rational functions, but the one I'll be talking about is where both the numerator and the denominator are both linear functions. But first, what are linear functions? Linear functions are functions that when graphed, they form a straight line. It's that simple.